In this exercise, we are going to measure the capability of the process. In this, the cable wire must be within the specification of 5 plus or minus 0.8 centimeter in diameter. Every hour, the analysts take 5 subgroup of consecutive cable, and all the data is also arranged in a single column. So first thing, let us calculate what would be the lower specification limit. In this, 5 minus 0.8, that is 4.2 centimeter would be the lower specification limit. Let us calculate the upper specification limit. 5 plus 0.8, 5.8 would be the upper specification limit. So our objective here is to comment on the capability of the process by calculating CP, CPU, and CPL, and then calculate CPK, both on CP and CPK. If it is greater than 1.33, we would say that the process is capable to meet the specifications. So let us now go and do this exercise in R. Let me share the R screen. Now you would be seeing the R screen, and it's in this, we have opened the file called capability study exercise and imported in it based on the last exercise. In this, we are seeing in the last exercise, we have used diameter 2 column. In this exercise, we are going to use the column from diameter 2. Earlier it was diameter. Now we are going to use this particular column in order to measure the data. Let us just open a sample script file, which I have already made and kept in it. So first, since the data is arranged in a single column, we need to arrange it in groups, which is requirement for the package QCC. Let us name samples.diameter, the same one which we have also. Now, in this case, let us make into samples.diameter 2 so that we can distinguish earlier and the new one. So let us make this as let me share the screen because the screen is now not appearing. Now you are seeing the screen. So now let us try to arrange it in groups. QCC, for the one of the command which you use to arrange it in groups in the requirement of QCC command is called QCC groups. And we would give where the data is stored. The data is stored in the file capability studies. And it is stored in the column diameter 2. And where is the information about the sample given? For that, we have to specify it clearly, capability studies, and the sample group information. So once you execute this command, you would see that this particular command is being executed. And let us see how the data is arranged now. Now you can see instead of a single column here, now the data is arranged as per the requirement of this particular command into groups. Now let us try to execute the command by creating specifications of the process like lower control limit, upper control limit into the data frame. For that, we will use a data frame called capability 2, and we would store those by making use of the QCC command. For that, first we have to specify where the data is. The data is in the main in the data frame samples dia.2. Then we will mention what type of chart we are trying to plot, so that, and this is an X bar chart which will calculate that information for us. And actually we don't want to do any plotting, but rather we want to calculate that. That's why we are using a command false. Whereas when we were using X bar and R chart, this command was not given. So now you will have the information of this in this particular data frame called capability diameter 2. Now let us calculate the process capability. So process capability is calculated by the command process capability. And now we are going to give where exactly the information about the process is given in the main frame. And that is in this particular data frame called capability diameter 2. And the specification, if you remember in this example, the specification, the lower specification limit was 4.2. Upper specification limit was 5.8. And the target of the process was 5. And now when you see this particular chart, you are able to see that CP value is 1.44, which is greater than 1.33, indicating the process is highly efficient. Same is the case with CPK, 1.41, greater than 1.33, indicating the process is very highly efficient. And it's almost producing 0% defects. So with this exercise, two exercises, exercise number 16 and exercise number 17, we have calculated the capability of the process using R. In the previous example which we solved in the class, we had solved the problems by hand, with the example of Nust Hotel School. Now the same example we have tried to solve it using R, but here that we have used real life data in terms of this process, whereas in the example of Nust, we had the mean and the standard deviation given, whereas here we are calculating the mean and standard deviation of the process and automatically we are calculating how capable our process is. With this, we come to an end of this module on capability studies.